half-angle formulas are used to find the sine, cosine, or tangent of measures that are not commonly found on the unit circle. With half-angle formulas, you can usually divide a known measurement by 2 to figure out the one you're solving for. You have your sine formula, which is equal to the angle you know divided by 2, which will give you the half angle, the measure that you're looking for, which is equal to the square root of 1 minus cosine of the what you know over 2. You have your cosine formula, which is your known measure divided by 2, which is equal to the square root of 1 plus cosine of the measure you know over 2. And then you have tangent of the measure you know over 2, which is equal to both 1 minus cosine of A over sine of A and sine of A over 1 plus cosine of A. So for the first problem, we're going to be taking a look at sine of 15 degrees. So since sine of 15 or 15 degrees is not on the unit circle, we have to figure out what angle it is half of. And 15 degrees happens to be half of 30 degrees. So we will just plug in the formulas that we got from the equations earlier on in the video. So we have sine of 30 over 2, which is going to be equal to the square root of 1 minus cosine of A, which is 30 over 2. And then I'll just substitute the value real quick. And so now we need to figure out where cosine, or basically 30 degrees in general, lies on the unit circle. So 30 degrees lies at the square root of 3 over 2, 1/2. That's where 30 degrees lies. And so then we're going to have to put that into the formula. So we have the square root of 1 minus, which x is cosine and y is sine. So since x is cosine and this is our x, we're going to input square root of 3 over 2 divided by 2. And then from here, we're going to change 1 into something we can subtract up top so they have common denominators. Two over 2. And then from here, from here we're going to subtract basically the top because we have common denominators now. So we're going to have 2 minus the square root of 3 over 2. Hold on. And then from there, we're going to multiply both the top and the bottom by 2. And that's going to give us exactly and then since we know we can find the square root of 4, we can just take it out and do the square root of 2 minus square root of 3 over 2. And that's it. That's sine of 15. Now we're going to do cosine of 112.5. And since 112.5 is not on the unit circle, we have to figure out what value it's half of. And it just so happens to be half of 225 degrees. That's what that is. And so we're going to need to know the unit circle point for 225 degrees. And so that is negative square root of 2 over 2. Negative square root of 2 over 2. And both of these are negative because 225 lies in the third quadrant, which both x and y are negative. And so we're going to use our cosine formula for half angles, since we're dividing the angle in half, which is cosine of a over 2 is equal to From there, we're going to input what we know of cosine of 225 degrees, because we know cosine is always x, so we're going to be using this value. So it's going to simplify to 1 minus the square root of 2 over 2 over 2. And then in order to subtract the top numbers in the numerator, we're going to have to change 1 into the common denominator, which is going to equal and this simplifies into and then now we're going to multiply both the top and the bottom by 2 so that we can cancel out the denominator, and that's going to give us, and then we can square, since 4 is the perfect square, we can square that, and that would give us the square root of 2 minus the square root of 2 all over 2. That is correct, yeah. And then now, for the final one, we're going to do tangent formula. So we're going to be doing tangent of pi over 8. And so since we know that pi over 8 isn't on the unit circle, we have to figure out which, what half is it? Is it half of which known point on the unit circle? And since we know that 1/8 divided is half of 1/4, it leads us to believe that pi over 8 is 1/2 of pi over 4. And so then we're going to basically just put it into our formula, which is the tangent of 2 is equal to 1. Sine of A, and we're going to use this one just because it's the first one and it's easy. And so from here we're going to substitute our values we know. Actually, we need to figure out where the square root of pi over 4 lies on the unit circle, and it just happens to lie at the square root of 2 over 2 and the square root of 2 over 2. It's at 45 degrees, and so that's where it lies, in quadrant 1. And so we're going to input the formula here. So we know x is cosine, so 1 minus the square root of 2 over 2 over the square root of 2 over 2. Now we're going to change the 1 into a value we can subtract from at the top. We're going to change that into 2 over 2, so equal to 1 over 1 minus the square root of 2 over 2 all over the square root of 2 over 2. We can simplify this even further into 2 minus the square root of 2 over 2 all over the square root of 2 over 2. And then this, we can multiply now both top and bottom by 2. Or 2 over 2, I guess that's the same thing. 2 over 2. And that would give us 2 minus the square root of 2 over the square root of 2. Now I'm going to And then from here, we have to get the radical out of the square root, because you can never have a radical in the square root. So we're going to bring it back up here. And we're going to multiply both the top and the bottom by the square root of 2 over square root of 2. This times this is going to equal 2. Since you have to distribute it to both this value and this value, it's going to be 2 square roots of 2 minus 2. Because the square root of 2 times square root of 2 is just 2. And then now, we look like we can divide all of our values by 2. And so 2 square roots of 2 divided by 2 is the square root of 2. And then 2 divided by 2 is 1. So we know our tangent of pi over 8 is equal to the square root of 2 over 1. And that's the beauty of half-angle formulas.